Blue Origin is one of the largest and most well-funded aerospace companies in the world, and so far, they've managed to establish a solid reputation as the laughingstock of the online space community. We love taking the piss out of Jeff Bezos and Blue Origin. It's a lot of fun, and while Blue might get the most attention for launching rich folks into space on a penis rocket, they've also been quietly developing one of the most important rocket engines of the 21st century. The BE-4 is an engine that the United States desperately needs right now to maintain their presence in low Earth orbit. So the question remains, can Blue Origin finally deliver? This is the Space Race. Okay, so instead of jumping straight into a bunch of technical specifications that I only pretend to understand, let's first talk about why this rocket engine is so important, because this is no exaggeration on our part. The BE-4 is critical to the future of American rocketry. This thing has to work. The BE-4 will power Blue Origin's own New Glenn rocket, the company's first orbital class vehicle, which also happens to be one of the largest rockets ever designed, featuring a 7 meters diameter cargo fairing and having the added bonus of a fully reusable booster stage. But this is not the reason that the BE-4 is important. As far as anyone can tell, the only missions that are critical to the specific capabilities of New Glenn are going to be Blue Origin's own orbital reef space station deployment, and also their undeveloped Blue Moon lander for the Artemis 5 lunar mission. Now, those are both really cool. We're stoked to see them happen, but they're not immediately critical. What is important right now is getting a new American rocket into service that can handle medium to heavy lifting duties for NASA, Space Force, and the private telecommunications industry. The United Launch Alliance Atlas V has been a workhorse rocket for the US space program since 2002. This vehicle flew 97 successful missions over 20 years, delivering important payloads to low Earth orbit, geosynchronous orbit, the ISS. It landed rovers on Mars, sent probes to orbit Jupiter, out to Pluto, and even into the Sun. It's just a spectacularly versatile and reliable rocket, but it suffered from one fatal flaw. At the heart of the first stage booster on the Atlas V is an RD-180 engine, an incredibly powerful dual combustion chamber, dual nozzle kerosene burning rocket engine. It's a fantastic piece of Russian engineering. And there is the problem. A Russian engine powering an American rocket. I don't need to explain why that's problematic right now. And operating alongside the Atlas V for the past 2 decades has been the ULA Delta IV Heavy. This is a vehicle specifically designed for getting very heavy objects into very high altitude orbits, so it did a job that Atlas V couldn't, but overall lacked the versatility. Delta IV has only flown 15 missions since 2004, most of them being top-secret military payloads. Delta IV made a name for itself as the most badass heavy metal rocket ever because it literally lights itself on fire in the seconds before launch to burn off excess hydrogen, and then this trio of charred black boosters emerge from the fireball. It does look awesome. Anyway, the Delta IV Heavy has one more launch remaining before it is permanently retired by ULA. The company's plan has long been to consolidate the Atlas V and Delta IV into one single rocket that can match the capabilities of both, and this is the Vulcan Centaur. Vulcan Centaur pairs the size and payload capacity of the Delta IV with the versatile form factor and efficiency of the Atlas V. The biggest change from the Atlas V being the replacement of the dual-chamber RD-180 Russian engine with a pair of Blue Origin BE-4 engines. So we have 2 of the most important rockets in the United States that have already been discontinued, and those are both set to be replaced by one single new rocket design, and that new rocket is going to be powered by a Blue Origin engine that is also brand new and has never even been flight tested before. Oh, and one of the BE-4s that was on its way to be fitted into a future Vulcan booster just exploded on the Blue Origin test stand a couple weeks ago, casting some pretty serious doubt on Blue's ability to manufacture a consistent product. The stakes are very high on this one, so we ask again, can Blue Origin deliver? On June 30th, Blue Origin experienced the rapid, unscheduled disassembly of a BE-4 engine at their testing facility in West Texas. According to the company, the engine failure occurred 10 seconds into the test burn. No video has been released to the public, but according to the people who have seen the film, the explosion was dramatic and caused heavy damage to the testing infrastructure. Now, obviously, some amount of explosion is going to be natural to the testing process of a rocket engine. It is a good thing to find the physical limitations for this kind of hardware so that you know exactly what it can and can't handle. Elon Musk had no problem admitting that SpaceX has blown up a bunch of their Raptor engines on the testing stand and will likely continue blowing them up as they push forward with the development of Raptor version 3. Where things start to get troubling, though, is when we see Raptors blowing up in mid-flight like what happened with the first test flight of the Starship. Failing in a test stand is expected, but failing in a vehicle is dangerous at the least and catastrophic at the worst. The BE-4 engine that exploded in June was on its way to become flight engine number 3 in the second build of the Vulcan Centaur first stage booster. One complete Vulcan booster fitted with 2 BE-4s has already been flight certified and is awaiting launch. So what happened to engine number 3 then? If the product was already sold to a customer, then Blue Origin shouldn't have been doing any kind of experimental stress testing to push it towards failure intentionally. You would think that the test in question was simply to confirm that the engine was operating with spec before going out to ULA, which it clearly was not. So either there is some fundamental flaw in the BE-4 that affects the reliability of the architecture, or this particular engine was just a victim of poor workmanship. Basically, it wasn't put together properly. Now, obviously, an error on the production line would be a lot more simple to correct than a baked-in design flaw, but neither outcome is good, and we don't know the full story yet. The biggest problem here for Blue Origin is that according to their own description of the BE-4 and its performance characteristics, there really is no good reason for it to have failed at standard operating spec. So let's elaborate on that. The line that Blue Origin loves to use when describing their engine is the BE-4 was designed from the beginning to be a medium-performing version of a high-performance architecture. So the SpaceX Raptor is an ultra-high-pressure, full-flow staged combustion cycle engine that is designed to push the limits of what is physically possible with a chemical rocket. It is a high-performance version of a high-performance architecture, and that's why SpaceX has had so many different iterations of the Raptor design and why they are still having trouble with harnessing the power of this engine, while the philosophy at Blue has been to make an engine that would be capable of Raptor-like performance, but to never actually push it anywhere near that edge that SpaceX is riding. So, for example, the combustion chamber pressure on a SpaceX Raptor 2 is 4,400 psi, and with Raptor 3, they are now pushing that to 5,100 psi. Over at Blue Origin, the chamber pressure of BE-4 is 1,940 psi, which is obviously going to be much easier to contain and control. Makes sense, right? Blue says this is a conscious design choice made to lower development risk while meeting performance, schedule, and reusability requirements. Which is all fine and good, except the engines are blowing up under a standard pre-flight certification test, which doesn't really support Blue Origin's design theory, does it? We draw so many comparisons between the BE-4 and the Raptor because these are two of the first rocket engines to utilize a new type of chemical fuel, which is liquefied natural gas, also known as methane. Obviously, methane is nothing new. It's been around since the birth of the universe, but the process of cooling it down to a cryogenic temperature to make liquid rocket fuel is a very recent development, and so far, no one has been able to get a rocket all the way into low Earth orbit using a methane-powered engine. There have been attempts. Dealing with liquefied natural gas, or LNG, is a lot more complicated than your typical rocket fuel, which is just a purified version of kerosene. But LNG does have some major benefits. For one, LNG can be used to self-pressurize its own fuel tank. This is known as autogenous pressurization. So, the way that rockets are designed, they need to have a certain amount of internal pressure inside their tanks in order to stop them from collapsing in on themselves. And because methane has such a low boiling point of negative 161 degrees Celsius, it's going to start evaporating into a gas pretty much as soon as it gets pumped into the fuel tank, and it's going to continue to boil off throughout the launch process. That gas is going to create enough pressure to maintain the integrity of the fuel tank. So even as the liquid is burned away during flight, the gas will keep the tank full and keep the rocket body strong. If you look at the SpaceX Starship as it's being prepped for launch, there is a big white cloud shooting out from the side of the rocket. That is excess methane gas being vented from the fuel tank to regulate the internal pressure. With a rocket fuel like kerosene that stays liquid at ambient temperature, you still need something to fill the void and maintain tank pressure, so rockets will use big canisters of helium gas. Helium is currently in short supply on Earth, so we should be conserving it as much as possible. So that's neat, but the real advantage of methane fuel is that it is clean burning. Now, that's not to say a methane-burning rocket is environmentally friendly. It still releases a bunch of carbon and greenhouse gases into the atmosphere, which is bad, but the burning of methane and oxygen doesn't leave behind a solid carbon residue on the internal components the way that a long-chain hydrocarbon like kerosene does. In order to reuse a kerosene-burning engine like a SpaceX Merlin, you have to go in and scrub out all of the leftover carbon deposits from inside the engine. Obviously, this doesn't stop SpaceX from reusing Merlin engines on the Falcon 9 booster, but it's not ideal. So, in theory, a methane engine should be capable of rapid reuse, meaning that you could land a booster, return it to the launch pad, refuel, and fly again, all within a couple of hours. Elon Musk talks about launching the same Super Heavy booster up to 3 times in one day. This is going to be critical for the New Glenn, which is supposed to have a fully reusable first stage booster, and the capability is also going to be taken advantage of by ULA with the Falcon Centaur. They don't have any plans on trying to land the entire booster core, but ULA has developed a system where the thrust section of the booster will separate following main engine cutoff, and it's going to deploy an inflatable heat shield that will allow the 2 engines to safely fall back to Earth and land in the ocean, where they can be recovered and reinstalled in a new Vulcan booster. So even though the idea of reusing an entire rocket booster is still out of reach for most rocket builders, the BE-4 opens up the capability for them to at least reuse the engines, which is still a massive improvement over the old system. So Blue Origin's first orbital rocket engine is a very important piece of hardware, not just for themselves, but for the entire spaceflight industry. But in true Blue Origin style, the BE-4 is also a bit problematic and unpredictable, which is about as much as you can expect from an aerospace company that has yet to actually get a product into outer space, but it's definitely going to make for an interesting story to follow in the months and years to come. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do 1 long form essay and 1 news update every week. And if you'd like more, we've got 2 more on the screen for you right now.